Let's cover objectives 4.1a and b. We'll solve and graph inequalities with a variable on one side or on both sides. Before we do that though, let's review how do you solve an equation. If you were given x plus 2 equals 6, all you need to do is get x by itself, and to do that you need to move the 2. It's plus 2, so you minus 2. And x would be equal to 4. Now in chapter 4 we're going to look at not equations but inequalities. And the difference is this symbol right here is going to be one of four things. It'll either be less than, which is this symbol, less than or equal to, could be greater than, or greater than or equal to. And when you hit Algebra 2, you actually have to know, what, if you see the symbol by itself, what it's called. The easiest way I remember that is these two point to the left, and therefore they're called less than. So the L in left is the same as the L in less. So let's start by solving letter A. It works the same way as equations, but it's an inequality, and this one here is less than or equal to. So to get x by itself, we need to get rid of the plus 2, so we minus the 2. We're left with x is less than or equal to 4. Now equation B is going to have a little twist to it. This one here though, we want to get z by itself, so we need to get rid of the negative 3 and the minus the 7. You work your way furthest out and work toward the z, so I'm going to get rid of minus 7 by adding. That's negative 3z is less than 15. Now to get rid of the 3, you divide by negative 3. Now this is very key. This is a star exclamation point moment. Whenever you multiply or divide by a negative number, you must flip the inequality symbol. So this will change to z is greater than 15 divided by negative 3 is negative 5. Now let's take this a couple steps further. This is an inequality with variables on both sides. Again, we're going to solve it just like we would an equation. After we solve this one, I'm going to show you how to graph the solution. So with this one, there's variables on both sides, so we can first choose if we want to keep the x over here to the left or over here to the right. On inequalities, I like to keep the x on the left-hand side. It just makes it easier for when I graph it. So because of that, I'm going to move the 9x, so I have to minus 9x from both sides. Now, don't switch the inequality symbol because we're minusing. Minusing is fine. It's just multiplying and dividing by a negative. So it'll be negative 5x plus 5 is greater than negative 10. Okay, now to get x by itself, let's move the plus 5 as minus 5. Again, that minus is not going to make me flip the symbol. Now to get the negative 5 out of there, I'm going to divide by a negative 5. So let me move that over here. Now because I divided by a negative 5, this time I actually must flip the symbol. Negative 15 divided by negative 5 is a positive 3. Okay, now we have it solved. Now we're going to graph it. So what you do is you go put a point at the number, what it's stated, and it's the number 3. So I go to 3. You have to decide if you do a closed solid circle or an open circle. If you have less than or greater than, you do an open circle. If you have less than or equal to or greater than or equal to, you do a closed circle. So when I see that its x is greater than 3, I'm going to do an open circle, and then you just read it as it says. Remember, if it points to the right, that's the greater than. So I want all the x's greater than 3. What numbers are greater than 3? Is it the 4, the one on the right hand side, or is it 2? Clearly 4 is greater than 3, so that means I want to shade everything to the right. The other thing you're going to notice is the inequality symbol here is pointing to the right, and so is this arrow. If the x is the first component in your final solution, so it's x is greater than or less than something, then the arrow you draw will be in the same direction that you see in your inequality. Okay, well, let's solve another one. To get the x by itself here, there's only a variable on one side, so all I have to do is move the 6, so subtract it. Again, that's not going to cause me to flip the sign. To get x by itself, this last step, divide by -7. That is going to cause the sign to flip from greater than to less than. -7 divided by -7 is 1. Again, notice this is a less than symbol. There's no equal to. So at the number 1, I put an open circle. And just interpret it as it says. They want the x's that are less than 1. Are the x's that are less than 1 the numbers 0, -1, -2? Or are they the numbers 2, 3, and 4? Clearly the numbers less than 1 are over here to the left-hand side, and I draw the arrow. Again, make the connection. Notice this arrow is pointing to the left, so is the inequality symbol. Now, what this means is that there's many, many different answers to this inequality up here. It means I could choose to put the number 0 in there for x, and it'll work. I could put -1 in for x, and it'll work. I could put -2 in for x, and this statement will still be true. Versus in an equation, there's only just one answer. Inequalities have many different answers. You just follow the arrow, and it tells you all the answers that you're crossing.